Alright guys, welcome back to our learning series in Simple Shell. Now in the previous video we talked about processes. Now in this video we're talking about arguments to a running program. Now right here I have two instances of my virtual machine. Now you can see that I have two instances. Now they are not conflicting with each other because why? They have different process ID. Now I could verify this by doing this here, coming here, and also do this here, and you can see this return what process ID of what 2905, and then this guy return the process ID of what 1029. That's the reason why this guy is independent of this guy and they could run what simultaneously without any conflict. However, if I'm going to create, you can see I'm still on the same directory here. However, if I'm going to create a file on this guy here on process 2905, let's say I do touch text and I click on enter. If I'm running an ls here now, you're going to see text, right? Now if I do an ls here too, now you can see the same thing here, text, because it's on the same machine. Now if I'm going to remove it here, remember this process here is what 1029. Now if I'm going to remove text here and click on enter, if I'm going to come here and do it, now it's no longer there. So you could see though there are different processes that are running, but it's still on the same machine and there's no conflict. Okay, so let me just clear here, make here clean. Now we're talking about arguments to main, so just open, just do string argc, string an argument. And first things first, I'm just going to include my stdio.h, and then let me try and make a small documentation about this. So a program to describe strings and arguments to main. Return, yes, I'm just going to return 0. Then just going to say int main come in here, return 0, terminate this. Now arguments to main. Now what does arguments to main mean? Arguments to main means when your command line argument actually means that the argument that you enter in your command line. What I mean is this, just like when I typed in this guy here, vi string arg.c. Now these are arguments now to my shell, right? To my command line here. This is my command line. This is the argument I passed in for it to be executed. And then we'll notice that the first thing we always do is what? The name of the program, which is in this case is vi. You can also do ls. Now ls is the name of the program. The first argument we always pass in is the name of the program. Then the other ones we are passing are more like now arguments, right? So in the same vein, let's assume I compile. Now let's come in here and then let me just do a print so that there'll be something displayed to our SD output, standard output, and just say come in here. Then let's just say now if I'm just going to come in here, then compile this using GCC, now if I'm going to run this, the executable, you can see a program to demonstrate arguments to main, right? It's just pretty simple. Now if I come in here, now this is not really what means by command line arguments or arguments to main. Now if I come in here and I actually write passing more arguments, and I pass in more arguments to this, let's say I do this now, is Sammy, and then I run this, it's still bringing a program to demonstrate arguments to main. It's not like this our program here now is not seeing this, but there was no provision from the file that this executable was gotten from. There was no provision for it to acknowledge this guy here, so it's just going to ignore it. And it is really not because we did void here. It's not because we did void here, because if I still remove this void now and then still recompile, I want us to please take notes about this, and then I still run it using this, it's still printing the same thing. So it's not really because of that void there, it is because right from the file that this executable was compiled from, there was no provision to actually read the command line. Now if I want to make a provision for that, like my program should read this command line directly, probably I'm creating a software now, I'm creating a program in which I want the user to actually pass in argument directly to it, just the same way you have this GCC and then you are passing in just exactly like this. Now GCC is a program that was written, and GCC is a program that was written to accept arguments. So let's say my a.out is a program that I wrote. Now this a.out is not interactive because it's not accepting arguments, it's just there. You just click on run, it's just going to run. When you click on your enter, it's just going to run. So let's say I want to make a program just like this, that you have to call in my program. You have to call in my program here, and then you have to pass in argument, and then it's going to do something with it. How am I going to do that? That brings us to the concept about arguments to main. Now it's been declared, or it's standard, that our main function actually takes in 3 arguments, but in most general cases you will often see 2. Now the 3 arguments are actually int, argc, then char, argv, and char envp. Now these are the 3 arguments to main standard, but then this is the most common, argv. Now basically what is very, very important, it's this part here and this part here, not really the variable name, which is argc and argv, because as a matter of fact I don't even really like writing argv. I prefer writing my own as av and ac, that way saves me less keystrokes. And also I would also like to point out the fact that this, let me put this in the comments, point the fact that this right here, me saying asterisk av this, is actually equal to me still doing this, because we should understand that the name of an array or the name of a string actually decays to be a pointer. So therefore means that, keep putting space, so it therefore means that just this guy alone here actually decays to be something like this. So that's what I'm just writing here. Now what does AC and AV mean? So I'm just adding space to make this much more readable. Now I'm just going to exit this. Now AC is actually going to count the number of arguments on the command line. Now, how is it going to count the number of arguments? It's going to count it based on a certain delimiter, which is called what? Our white space. Meaning it's just going to know that this is where it's going to end and this is the next number with the help of what? The white space. Because basically, if you want to pass it, you have to actually press a space to signify the end of that and the beginning of another, right? So it's the same vein. AC is just going to count, and AC starts counting from 1. That means this becomes 1, this becomes 2, and so on. We start passing more and more arguments. But this here, if I enclose this and I do something like this, it's going to read this as 3, because now we've actually enclosed this in a inside a quote. It can be a single or a double quote. We've actually enclosed this in what? In a quote. So it's still going to read this as what? 1, 2, and 3, not 1, 2, 3, and 4. Please, I would like us to take note of that. Now, what does AV means? Now, AV means stands for what? Argument vector. Now, we should realize this is char start star. We should know that, okay, this is an array of strings. Since we know that a string is actually char star, right? So definitely char star star becomes an array of strings, and you know that strings are indexed, and their index starts from what? 0. So AV actually starts counting from what? 0. So this becomes what? 0, 1, and in the same vein. So AV starts counting from 0. AC starts counting from what? 1. It also means that AV at index 0 is actually going to be what? The name of our executable, or the name of our program once we are done once we compile it to an executable. AV at index 0 is going to be the name of our what? Of our executable. Okay, now I also want to point out that AV at index AC is always going to be null. Well, it's the reason is not far-fetched, because AC starts counting from what? 0. Sorry, AC starts counting from what? 1 and 2, right? And for AV starts counting from 0, right? So this is becomes what? 0 and what? 1. So therefore, AC at index AV is going to be null, signifying what? The end of what? That array of strings, and it's going to be put in there automatically by our machine, our compiler. They're just the same way when we put in a string. We are not the one. You can actually manually impute the null there, but then it's just going to be imputed automatically for us. If you still want to do that, well, you could actually do it by just saying, probably outside of it, anywhere in your this, you could just do something like this: AV at index AC. Then you want to just do, you could just do this now on inside your file there. You just put it there, and it's just still going to be, but then by default, once it's done reading, it's just going to add it there. So those are the points I would just like to bring to our understanding. So now we've actually made provision now for it. So that means we are ready to read in arguments. But if I'm still going to recompile this again, and then I run this, you see it's still bringing the same thing as though nothing changed. Well, something has actually changed. The problem here is that this now, it's now being saved to AV. AC now holds what? 3, which is 1. Sorry, AC now holds what? 4, which is 1, 2, 3, and 4. But the problem here is that we are not displaying this result to the standard output. We are not displaying this result. So now let's display this result. So I'm just going to go back to this program here. Then I'm going to come to this particular line here, so we could actually see it clearly and we could understand. I don't want to mix it up. So now I could come in here and say number of arguments with AC, then is going to be an unsigned integer because it's always going to be positive. There's nothing like -1 here. So I'm just going to put in my AC command. Now I can't do something like this, printf let's say argument vector, then put in %x, then come in here and do AV. Now I can't do this. Why can't I do this? Or I think this is the reason why I can't do that. Now our %s is actually going to print till it hits the null terminator. That's the way it works. So %s is actually what expecting what a data type of what's char star, because a char star is just a string, and we know that a string is actually not terminated, right? Just like this, because I can come in here, copy this everything here, going to copy it, then going to create going to create a variable char star. Let's just call it message. Let's just call it message. Then paste it inside here. Then I'm just coming here. And then I can say onto this display message here, and put in my %s, come in here and put msg, which is this. Now this is going to work perfectly, because why? We've declared it as what? A string. Now look at the declaration. This is char star and this is what? Char star star. Now %s is going to print it. It hits the what? The null terminator, meaning it's just going to print the word char star. So let's go first let me comment this, or if I don't comment this particular line out now, because I want us to kind of to listen, and then let's understand the gist. Now if you have any questions, you could drop it in the comment section, or you could reach out to me via WhatsApp or Slack, or probably by mail, and then you could ask your questions. So please, I would like us to listen and pay close attention. Now if I don't comment this out, if I don't comment this guy out here now, if I don't comment this guy out, it's not going to compile, because the reason why it's not going to compile here is because of this guy here, because %s is expecting char star, but AV is of the type what? Char star star. So now first thing, I've commented this out. Now I want to print. You see that? Now I want to print. Now you could see, now it displayed what? The display message. You could see it. Now let me go back to my program and remove this comment. I think this is too long. Yeah. So let me come in here and then I'll remove this. Remove this now. Now you could see the problem just the same way I said it. You will see it. Now this is what is actually happening when we say this as what? Char star star. It's now going to be stored in an array of string, in the sense that here is the first string, then on this space here The null byte is included there to indicate the end of this. On this guy here too, the null byte is going to be added here to verify the end of this, and that is the way it's going to be stored in memory because of the way we declared it. We declared it as what? Char star star. We didn't declare it as char star. We only declared it as char star, though there was white space here, but it printed it out because why? At the ending here, that was where the null byte was included. That means at the ending of this guy, this point, this here in memory, at the ending, this is what is being used to signify the end of string, as against when it is char star star. Hope we get the gist now. All right, now we also know that AV at index 0 is always going to be the name of our executable, right? So if I do something like this now, we've already seen that it didn't print out. So if I do AV now at index 0, AV not at index 0, we are now going to print out the name of our executable. So let's just say, let me reduce this to AV at 0. Now AV at 0 is now going to be the name of our executable in which we compiled it to be. So I'm going to then do this. Now if I'm going, now let's see, now this is the name of our executable, right? I think I should just use this terminal here. Read it out. Then let's say this is Sammy. Now you can see, because why? It actually starts counting from what? 0, 1, 2, and 3. Now to actually verify if AV at index AC is actually null, I could come in to this place here and just do a conditional statement here and say if AC, I could just say if AV, sorry, at index AC is equal to null, then let me just printf, and just say null. Then let me put in an else statement to see, because we are just kind of checking, right? Then we just say printf no. So if this condition is true, then it's going to print no. If this condition is not true, it's going to print no. I can actually come in here and shorten this here to be this, and it's still the same thing. It's still the same thing, because if you check my GitHub, you will mostly see some of my conditional statements or some of my conditions, probably in a while loop or in an if loop. I'm kind of using this annotation. Yeah, it's actually meaning the same thing. So, but then let me use the one where to make this very, very beginner friendly. So I'm just going to compile this, then I'm just going to run it here. Now you could see the null, but then I didn't put in the new line character. Oh yeah, that's true, I didn't put in the new line. Sorry, I didn't put in the new line there. So GCC change this, or not this is some, yes. Now you could see it now, no, meaning that meaning that this condition returns what? True. So av at index x is always what? No. Now if I want to also print av now at index 1, I could just come in and put in 1, right? Then change it to 1. Now compile this. Now if I've changed it to index 1, it's now going to print out this the second argument, right? So now you can see this. You see this is printed. But now the thing is, I can't always, the limitation here is that I always have to come in here and change this. Now how what other way can I achieve this? Well, I could actually achieve this using what? A loop. Using a loop. So my loop, I think my loop condition now, we could actually just even on that get our loop condition. Now our loop condition should be while ac, or while av rather, or yeah, while av at index ac is not equal to null, right? And then you could start decreasing. You could start decreasing your ac. That's if you want to print it in reverse. We should print in reverse. Now for printing in reverse, now that's we'll be shortening, because we already know that av at in the ac is null. So if ac is 4 or 10, if we want to, we'll then do ac minus 1, which is 9, then start decreasing ac by 1, then we are printing in reverse. But we don't just want to print in the way it is being passed. We don't want to print it in reverse. So let me take this. So I'm going to use a while loop. You could use any loop. Just quick to use a while loop. So I could say while av at index. So since I'm going to use this guy here, I don't think we need this here again. No, we don't. I don't think we need this. So I'm just going to declare an integer, then initialize it with 0. So now everything is looking readable now. Then I could come in here and say while av at idx is not equal to 0, that's the meaning here, is not equal to 0, or in this case now is not null, because 0 in ASCII will translate, since this is string, is going to translate into a null. It's null. So I could then do printf, then I could then do av at %d, because I want to be printing the index. Then it's going to be a string, and then that's all. So the first one there is going to be my idx there, then the second one there is going to be av at idx. Then I'm now increasing idx. So that's one way I could achieve that. I could also achieve that by saying while idx is less than ac, because we know that ac is the number of the counts, right? And we've already said that idx is 0. So I could do this and then it will work. I could also say while idx is not equal to ac. So when idx equal to ac becomes null, it becomes that condition becomes false, so it's going to exit. So you can see I've already written 3 conditions. The bottom line is you understanding what you want to achieve. The bottom line is you getting to understand what is happening, getting us to understand the concept. Oh wow, this video is getting too long. It appears I will have to split this into part 1 and part 2, because I will need to still talk more on the string splitting. So let's just print this out, and then I'll just touch in on the void arguments. So Okay, so let's use this way. You could say y idx is not equal to ac, then an half. Okay, all right, now it's looking very readable, So as a quick summary, we included the header file because in this stdio.h header file, it's where this our printf function is defined, in which we are using. Then we've actually said our main function is going to be accepting argument, which is ac and av, which are arguments to main. Then we've actually declared a variable which is idx, and then we've created a string, we call it message. Then we did this printf, and we're just passing this file up there. So I'm going to do gcc here, and then so this is something. Now you can see it printed everything out. First one, yeah, second one, third, fourth. All right, okay. If I also changing now, let's see. Now I just remembered. Now let me use those flags, gcc flags. You see that we still didn't break any row here, so it's wall error extra. Yep. Now I'll change this. So let me change the output file. Let me change the output file name to be arg. It is 0, not it is O, not 0. Now you can see it's compiled properly. Now because I've changed, now if I'm going to do ls, now you see that a or and arg is still there. This screen is looking cloggy. Now I want to run this. Now let's say we are testing arguments. Oopsie. Oh, this is now conflicting with I didn't. Sorry, I have to do this. Sorry, I have to do this. Yep, sorry about that earlier. The arg itself, it's just like this ls here now. So the arg, it's a command, and it's a command, so it was conflicting it, so it was giving me suggestion. So that's just we could see now. Okay, yeah, we could see now that you see we have arg test and arguments. Now we could still go back in here and actually changing the condition, and then it's still going to work. Well, with that said, we've actually talked about this now. This guy here, arguments to main. Now what does it mean using void arguments? Now what is void arguments? Now these are arguments that are not used. Now right here, now I can come in here. I could come in here and comment this. Oh well, I think I'll do this in the next video. Because this video is already getting long. So alright guys, see you in the part 2 of arguments to main. God bless you all. Take care.